All right, this is our second video on recursion. It's the one I promised you about numbers, maybe clearing up the the part about coming out of each function call, going in reverse order. All right. I'm just going to do a function that adds up consecutive numbers. All right. Look down here in main. I've got start 3, end 6. All right. And all I'm going to do is see out the sum of recursive sum, R sum, start and end. So this could be 1 in 10,000. For this demonstration, I'm going to make the start 3 and the end 6. It's going to add 3, 4, 5, and 6 together. All right. Let's look up at R sum. All right. I send it to two integers, 3 and 6. Inside this function, it's going to see those as m and n, not start and end. It's going to see m and n. And this is my base case. If m equals n, comparative operators, return m. All right, so in this one, I put return m, but it could have been return n because they equal each other. All right, so that's the base case. Every recursive function needs a base case, or you get an infinite recursion. And I guarantee you it will happen to you. If you do anything with recursion, you will forget the base case or not put in the proper base case, and the screen will just roll with something. Did it many, many times. So that's the base case. This recursive function is going to keep calling itself until it reaches this base case, which kicks it out. And this is just with when m equals n. All right. Here's the actual working part of this recursive function. Return m plus r sum m plus 1. Notice inside of this, on the first time through, it's going to just take m and add r sum incremented by 1, and it sends it n again, but n does not change during this. Somehow it makes it a little easier if you think about that. The end never stays the same. The beginning goes through and just increments 1 each time. So m is going to be 3, 4, 5, and eventually 6, which is the base case to make it kick out. All right. So this is going to be 3 plus r sum. And now at the next, it's going to send it 4 and 6. Initially down here, it sent it 3 and 6. And then you can see that it'll go through again and add it over and over again. This kind of clears it up a little bit about what's going on and the backwards, how it pops off at the end. All right, the first time through, we're going to send it a 3 and a 6. So it gets up here and it compares them. They're not equal. It goes to the else. So it's going to be 3 plus, and I'm going to use just parentheses as the recursive function. All right. So basically after the first time through, it goes through and it's 3 plus the recursive function. All right. But when it calls a recursive function, it increments it. So it sends it 4. All right. N doesn't change. So it sends 4 around to do it again. Okay. So it goes through there. 4 does not equal 6. Then we're up to this again. It's going to be 4. All right. We're up to this call. 4 plus the recursive call. All right. 4 is okay. So now we pass that along. 4 plus 1 sends it 5. 5 and still 6 because it does not change. All right. Gets back down. 5 does not equal 6. Then we get 5 plus recursive call. All right. Right. Then it increments again. 5 plus 1 goes up here, sends it to the function. 5 plus 1 is 6. 6 equals 6. It returns 6. So this last time, we just put a 6 in here. All right, it's done. But now for the actual calculation, you have to think what happens. You remember back to the days with PIMDAs, you do what's in parentheses first. So the first thing is you're going to do what's inside the innermost parentheses. All right. Okay, now you get 5 plus 6. You do that. See how these are popping off in reverse? 11. All right. You got 4 plus 11. You do the math on that. Equals 15. And that just equals 16. So that kind of gives you a visual representation of the popping off, how it works in the end. Doesn't do it going down. It really does it coming back. You do the math on this. And there's your 18. This is actually fun, one that's fun to play with. Change this to 1. Change this to, I don't know, 1100. That's 605,550. All right. If you're having a little bit of problem visualizing the coming out of the recursive calls, watch this video again. I'm gonna have some more. One of my videos I may send you. I'm gonna watch it and see how it looked. I did the Fibonacci video last year. You might be receiving that after this one. I don't think you can get enough instruction on recursion because, like I said, it's just not intuitive. It's unless you're like an ultimate math geek. If you're an ultimate math geek, maybe you see into it a little bit sooner than most people do. But I remember I kind of struggled with it a little bit at first. It gets easier. Just rewatch these videos if you need to.